Let us look at addition of vectors. Now, suppose you have a table here, a heavy table, right? And you need to push this table from one end of the room to the other, right? You're pushing on this table, and you're pushing this table with a force of, say, 400 newtons. 400 newtons is a little less than the amount of force that you can use to lift a bag of thin set that is used to lay tiles. Alright? It's about 50 pounds or so. 400 newtons is a little less than 50 pounds of force. So you're pushing the table. Then you have a friend who comes along to help you to push that table. So this is your friend helping you to push the table. Alright? And your friend is exerting a force of, say, say 300 newtons. Alright? 300 newtons. And this 400 newtons plus this 300 newtons, you could replace it with one big force. You could just say, imagine that you're pushing with a force of 700 newtons. Now, how you get that? It's just a matter of saying 400 newtons plus 300 newtons is equal to 700 newtons. So in this case, you just add the numbers, and because they're really going in a straight line, all right? If somebody was looking from the top of a stair, say they were upstairs looking, they would see your friend, all right, pushing the table, and they would also see you making your efforts pushing the table. And what they would see is your 400 newtons and also your friend's 300 newtons, like that. So you add these forces. I'm representing these forces using vectors. You add these forces like that. So you have a total of 700 newtons pushing the table in that direction. All right? Now let's look at another scenario. Let's erase all of this and look at a different scenario. Suppose now you have two persons and they're in a bit of a competition. You're saying who is stronger than who? And they're trying to push a table. One of them is here pushing the table, and the other is over here also pushing the table. All right? Now, this person in green is pushing the table with 500 newtons, the 500 Newton force this way, and this person in red is pushing the table in this direction but with 450 newtons. The question is, who will win? In what direction will the table move in this show of strength? Now you can see that the person in green is pushing to the right with a greater force. So the table will move this way, and the person in green will win this competition. But guess what now? If you consider 500 newtons to the right as positive, that's 500 newtons, plus, and then the 450 as negative, 450 newtons, then the answer you get here will be 500 minus 450. 500 minus 450, which will be equal to 50 newtons. So 450 will cancel out 450 of the 500, leaving 500 left over. And then what you have is equivalent to 50 newtons acting to the right. So that's what you have. So that's the case in this. You have 500 minus 450, which is 50 newtons. Now, another scenario where we're going to add vectors. Remember, when we're talking about addition of vectors, in some cases we'll actually be subtracting because we're considering moving to the right, left to right as positive vectors, right to left as negative vectors. Now, we are in a situation where we have what is called a tug of war. Alright? We have 3 persons on each team. We have the tree, and we have a rope being pulled. Let me draw my rope using a straight line, pulling this rope. And then you have 3 persons on the opposing team. Pulling the rope in the opposite direction. Alright? Now, the barrier is in the middle, and anyone whose foot comes over the barrier, their team loses this competition. Now, suppose we have the green team pulling to the right with a force of 1,500 newtons, and the red team pulling to the left. Now, if the red team manages to muscle up enough to pull with 1,530 newtons, the black team, I should say, not the red, the black team over here is pulling with 1,530 newtons and are able to maintain that, then they will overcome the green team and pull them to the left and win. So, in this case, what we have is a negative 1,530 because they're pulling to the left, plus 1,500 newtons because they're pulling to the right, equals, when you add them, you will get negative 30 newtons. So, the 1,500 on each will cancel each other and leave 30 behind. So, in this case, the team pulling to the left will win because they are pulling with 30 newtons more than the team pulling to the right. So they will drag them over the barrier and win this competition. Alright? In other words, if you represent the vector acting to the left, let us say 100 newtons represented by 1 centimeter, and each of these divisions on my graph here is a centimeter, and you would have 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 11, 12, 13, 14, 15 to the left, plus 30 more, so you go a bit more, and then to the right it will be 15 exactly. So what you have in this case is 1530 to the left and 1500 to the right, and this now is the 30 that the black team wins by. Alright? So what you have is that the sum will be this vector, because all of these parts will cancel each other and 30 newtons will be left over. Alright? So that's an addition of these vectors, which involves some amount of subtraction as well. Now, if the green team pulling to the right, if they are able to muscle up really hard to pull and maintain more than 1530 newtons, for example, they're able to muster up enough strength to pull with 1535 newtons, then they will win, because they will be 5 newtons more than the black team pulling to the left with 1530 newtons. So what you will get now is negative 1530 plus 1535, and you're left over with a positive 5 newtons acting to the right. So the 1530 and the 1530 will cancel each other, but there will be a 5 newtons left over. And then the green team pulling to the right will win this competition. It's a matter of representing the forces here using vectors, where in this case the magnitude of the vectors is represented by the length of these lines representing the vectors, and then the small length left over, in this case 5, represents 5 newtons, which is the strength that the winning team used to overcome the other team. Now, that's that. Now let's look at this scenario here. Suppose you're able to look down from upstairs where you have this table being pushed, and one person is pushing the table this direction with say 70 newtons of force. Then you have this other person pushing the table this way with 60 newtons of force. Now what happened? The thing is, you can't just add them and say 70 plus 60 or 70 minus 60. You can't just do that, right? These vectors are not lined up in the same exact direction or in opposite direction. They are at, in this case, 90 degrees apart. So how do you deal with this type of situation? How do you add these two vectors and what will you get? Well, we will deal with this type of scenario in a separate video. So I will see you then.